Hello everybody and welcome to this tutorial how to model a fun bathroom toy set with Shapr3D. In this video I will mainly narrate the process I used when creating all the individual sketches, like you can see here, and primarily focus then on the direct modeling approach I used to very quickly from this centralized set of sketches create actually variations of this design. The scene file is shared with you, so feel free to download and open it so you can follow it. If you start a new scene, make sure that the scene units is set to millimeters, and also all the snapping tools, as you can see here, are turned on. Great. Now let's take a look at how we can model those fun toys quite easily. Let me actually first turn off all these objects. Okay, and I would like to talk a little bit about how I set up the sketches first, to give you a little bit about of an understanding, maybe how to think about it, where do we place them, etc. So you know we have actually three different models. It's not only actually the color is different when we go back, there are also various details which are different. The eyes are different, the faces are different, the bottom parts are different. The back area is actually pretty much the same. The overall shape of the body is also always the same. So there's a lot of similarity between these three objects and some elements which are uniquely very different. Now you can, for example, for each object, create a new sketch if you want to, which of course works, but then if through the design process, let's say the overall body proportion we would like to change, then we would have to adjust three sets of individual sketches. Again, this is all possible. It just adds a lot of extra labor work. And that is why when you take a look at the scene and you zoom in, this first looks a little bit, I admit, in this view, very artistic, but there's a very clear process in how I'm using, for example, the front view, the side view. Also here you can see I have sketches which I created on the main plane and then I moved them away. So they're not all actually on the same sketch plane. For those who are not familiar with this, for example, here I would like to create something for an eye. The easiest way is simply I just create a sketch. You see, there it is on this plane. Then I go to transform, move, select this, and then I can move this wherever I would like this to be. When this is a closed shape, and this is very important, not just a line, a closed shape, and I would like to work on the sketch and have the grid projected onto the sketch, select it with a finger, double tap. And then you see when I start sketching and just add something and I slightly rotate, you see how the grid is actually moved to right where this element is. Okay, now, and then when I move further out, and then you see how the grid snaps back to the world definition. So you don't necessarily need, that's the reason why I point this out first before we go into modeling, you don't necessarily have to first create a construction plane, offset it, and then put a sketch onto that construction plane, which is something we're very much trained to do in parametric engineering programs. The beauty in Shapr is while we have actually access to construction planes, we don't need to. We don't have to put a sketch on a construction plane. We can simply sketch it somewhere and then just move it. For example, here, all these sketches you see here at the side, these are the individual sight lines I created for cutting the faces. And because I have three models and I don't want to have these three sketches all on each other, I created them and then later moved these sketches away. So I store them somewhere outside. And you will see in one, when we actually create one piece, we move it back into the center. Because I'm moving sketches from the XYZ plane away and back to, it's also really important you have your grid snapping turned on. Because then it's how could we say this? Peace of mind. Yeah, we can see where this is, and when we select this and go to move, it's so easy to simply move it back into the center area. Okay, so I think this basically covers most of the tips and tricks for how to move and position sketches. Now let's take a look at how we can very easily model part in the process. Because that's actually really the interesting element in direct modeling, the step-by-step and how we can think through the design. Maybe the way we will do this is we will focus on this body here first. So it's quite simple, not too complex. Okay. So you see here, I have the main body. This element is always the same. So I can select the profile by clicking into it, select an axis line, and then in the predictive toolbar on the left, I can do a revolve. Very good. At the end later, we want to shell this, but the shell command I will only do when particular features are already added to it, because I want the work to be very minimalistic. I don't want to have extra work. Now to cut actually this face into it, this is now where the move command will come in very handy. I select the sketch, go to top view, and then move this in there. Perfect. Now this is actually at the center. Very nice. In 3D view, this is important. I select these two lines. This might actually also be good practice then to turn on this show edge, because you can see now I can select these edges through the body. Pretty nice. Select this face, and then on the left side, the toolbar now gives me the project command. Now this sketch will be projected onto the surface, which is really cool because now I can select this new face, and you see, because this is a cylindrical shape, we created this via revolve, I can adjust the radius. I would like this to be 31. There. So I get a millimeter of an offset. Very nice. I'm going to hide the sketches for the moment, and I will turn this back off. A little bit of filleting strategies now we can do. So these actually I will round first, 10 millimeters. And then this resulting corner or edge, I break a little bit so it's not a sharp edge. Pretty cool. So the reason why I did this is now when I select this face and do a shell, 2 millimeters. Okay, you see there the inside is shelled. How cool is that? Huh? When we go back to our orange one, however, we also see here is this area that's carved out. So when I go back to here, then how do I now remove the opening, patch the surfaces in, and this is way too complicated. So welcome to direct modeling. Now we can always undo commands by selecting all the faces the shell command created and simply delete them. And we're back to this one. Really nice. At the back, there is the rectangle to create this flat surface, which is nice to put the suction cup onto it. So on this one I select, extrude into it, but instead of cutting, I would like this to join. Then again, filleting strategy. First round one set of corners by 5. This looks good. Then I can round another set of corners by 2. Very nice. Okay, so let's see, how does this look when we do a shelling now? There. I hope this quick demonstration already showed you Also how important it is to kind of like try to envision how the step-by-step process should be set up. And in case we make a mistake, like in my case, I shelled this before, I realized that maybe I shouldn't have shelled it. Now we don't have to undo something. We can just delete faces, get the original geometry back, and then restart from there. Pretty cool. So here now I could go ahead and start rounding all these edges more and more based on how I would like to do it. In my case here, I will actually skip this because this could be quite time consuming. It's a detail work. I'm not going to spend too much time on it, but you saw how I rounded this inner edge. I can also round this edge, and then all these edges, kind of like again, trying to follow logical filleting strategies, I can start adding. A little warning about doing too much filleting at the beginning. It's also very time consuming, and fillets can be a little bit tricky in general when we want to remove them. So this is something I really only do when my design kind of like is done. Fillets are a finish. They're not necessarily really a design feature. Very good. Okay, so let's do a quick hole at the bottom. I have this element here, which I can extrude and cut. Let's make a new body instead. When I selected a body by double clicking, you see I just created a new body. I didn't do a Boolean cut. Then I can move the gizmo to here, turn on this, to copy, and then make a rotation 180. Double tap both. This actually then should select directly the geometrical center. I'm just extra precise by moving this back onto the sketch. So I'm using actually the sketch here to snap to. Type in 60. Very good. Double tap and double tap and 60. Very good. So all those holes I will select, or they're not holes here, they're cylinders. I will select first, then I select the main body, go to subtract. I don't really want to keep those. Very good. And this is actually wrong. There. So you see, we can actually click on these icons to change what is a tool and what is the piece the tool's being removed from. Done. And there we are. Pretty nice. Now also there you see, logically, we drill the holes after we carved it out. Makes more sense. Okay. Let's take a look at the eyes. It's also pretty fun, and how this can be built. There. I have this circle, and I extrude it as a new body. You might ask yourself, why do I have this rectangle here? This rectangle I will revolve around this line. Okay. And then I select the cylinder, this new ring, and perform the intersect command. So only the shape or the volume these two objects create by intersecting each other will remain. So now I have actually from here a circle, and from the top you see the profile is arced. How beautiful is that? The two eyes should be very close next to each other. So as you see, I moved the 3D widget back to the center. Make a copy and 14 degrees. Very good. This one to here, minus 14. Very nice. These two we round. So here I will round it because this is actually really a feature. And I have these rings. I can project and project. So now I'm slicing actually the surface because then I can give each face also individual material. And all those we fuse together. To stiffen the top part a little bit, there is also a little ring here. So we select this, go to the axis, and do a, sorry, not a sweep. Another revolve. Now we have the problem that this revolve, as you can see, runs through an open space. I could revolve this instead of 360 degrees, revolve this less, and then mirror it, join it. But this is a little bit too complicated. I can simply hide the main body, do my revolve, and here is my original rectangle, and extrude it and cut. There. And join those. The reason why I also join this element at the end and haven't joined it before we did a shell is simply, and I will show you this in another version, well, this face here is arced. And then we would also have here this convex. Wait, no, this is convex, this then would be concave. And here I just wanted to have a straight, flat face, which is the reason why I need to add this afterwards. Very good. Here is the element for the suction cup. I select the profile, this edge, do a revolve. And then this one I would like to remove from this. So we select this first, then select this, subtract. And in this case, now we would like to keep the removed body. Okay, pretty cool. Let's give the whole thing some colors. When I double tap, you see the whole object gets a color. Now this is important that we tap somewhere else. Then I can select these two faces here, make this white, tap somewhere else to deselect everything. Select those two, and then we make this black. Cool, no? So easy. And we can select white, select the back, so the suction cup, double tap it, and then we lower the opacity. So this looks transparent. Very good. Now a common problem of computer graphics is what we see there. It looks like an artifact. In real life, the surface of the suction cup would sit on the surface of the plastic body. But because CAD is so precise, they're actually literally in each other. So this is the main problem. If visually this bothers you, it's actually very simple to fix. We can select this, and then instead of 4, we make this 3.9 there, and this one we make 1.95. So just a hair away. And you see, that fixes the problem. And I can do the same also in the inside. Very good. So that wasn't too complicated. No. This one I will delete. I will hide this. And let's take a look at, with all the stuff we have here, how we can very quickly now create another body. I first go to transform, select this outline, and move this back. Okay. And, whoop, sorry. I will select this one and move this in. So why do I move this actually in here? So the main reason is when I now do a project, it goes left and right. From here, the projection only essentially would hit this part of the cylinder. And that's not what I want. And then I would also have to make a copy on the other side and project it. So it's actually simply easier to have it moved into the center, do the project, because then it goes to the left and the right side. Also, this way I only have to deal with one sketch. So Also like how we did this before, very easy. See, I do exactly the same steps. So you can see how easy it is to very quickly generate from the same sketch various modifications. Very nice. I will select these edges. 0.5. There we are. I want to be nice and tidy. This is done. Let's move this back. There we are. When we move those in and out, you have to be careful that this actually will change the name of a sketch. Because here, let's select the sketch and this. They're all basically on the same plane, more or less, if you want to see it this way. And they have one name. So when now a sketch is moved onto the same plane, they're fused together. And when I select elements and move them out, for example, here, let's do it this way. You see, this is actually side profile sketch. I go to move, make a copy, move this out. And you see now this is called side profile in brackets 1. So it gives this a name. So that's the reason why these are called now sketch plane 11, because these were all moved to the center and then moved out, and that changed actually the name. But it's very easy visually to identify here what the sketches are. Okay, very good. So this design actually has a water element that flows out and also an arm that comes in. So let's continue the same modeling process we did in the past video. There and there. It's also very good to write these elements down. I have here also an ellipse. I would like to delete this for the moment and give you a tip. So there, we do a union. Now I would like to shell this one out. Sometimes this works based on dimensions, etc. Sometimes it can be problematic. We can also take this ellipse and make an offset. You see, however, how the shape changes. So instead of doing an offset of the ellipse, which turns this into a spline, I simply drew another ellipse and made along X and Y this uniformly smaller by 1 millimeter. So, whoops, sorry. Come on. I join this now. Should I? Actually, I should not. So, again, this is now where step-by-step process is important. Good. So this is cut, but how do I now do this? I can extrude, join, but this is not ideal. So when it really sinks in there, then it cuts through. How do we solve this? Actually, the match face or replace face command is super powerful. So we select this face and this face, and then on the left side, simply select replace face. There is an option for other side. So we pay attention to if the projection is correct. In our case, it is correct. Click done. And now this is a new object. And you see the bottom face got adjusted by being matched onto the target face. That's actually pretty amazing. So now we can select those two, join them together. And we will do the same command here. Let's see if actually the shell works. Sometimes it can work, sometimes it cannot. Shell is a very complicated command. So here, for example, only with 0.9 it does, but not really with 1. It's always good to know if one way doesn't work, there's definitely a second way. So I extruded this just a little bit because now I will select this face and say replace there. Extrudes it down and matches the face. So I have also consistent material thickness. So there's nothing that is a tick thicker, as you can see. Oh, awesome. Cool. Okay. I will turn this one off. There we are. Now we also have here the section cup. We do a quick Boolean command. So now there's the hole. Very nice. So the bottom part, how do we do that one now? Let's go to here. This is actually the outflow command. So I could join this, do a union, and now I realize, oh shoot, I actually decided to do this afterwards. And I can add it, but then it sticks through there, as you can see. So how can we fix this? Again, this is one of the nice features of direct modeling. And I will, I might have to just keep it there. Okay, very good. I was just trying to see if I can get this edge to stick out further. So in the design process, this sometimes can happen. Like you see right now that we add something to it. Maybe a client wanted to have this feature and then we realize, no, I can't shell this anymore. How can I make this work now without too much complication? And I also need to have a hole there later. Because I want to have a nice fillet, in our case, well, we need, unfortunately, to redo some of these steps. And again, this is not very complicated. The design we have is actually quite simple. So to remove these faces, as you can see, is not really that complicated. Bang, there we are. See, easy. And then here, all this, we shall 2 millimeters there. Okay. Now the bottom part is actually closed. So let's go back one more time. And also this edge, I would like to fill it. So I hope that in contrast to, for example, typical surface modeling where we do unstitching and untrimming and restitch and refill it, you see how fast it was actually to get to a previous stage thanks to direct modeling. It's pretty awesome. Okay, so we would like to have this and this face shelled at the same time. Okay, simply select those two faces, do a shelling, and there we are, including, that's the reason why I fillet this first, the inside edge is filleted too. Beautiful. Because we kept this as a body, I can also very quickly redo this. There we are. Not really complicated. Then let's actually take a look at the rest of the sketch here. We have some stuff going on here. So this I will extrude a little bit, and similar to the other situation, just do a match. Okay. Then we join this. We fillet this. And now this one, as you can see, I extrude through and cut. This is not really for water outflow. This is just an opening for a part to be pressed into. Okay. The amazing thing about direct modeling is, let me hide this and take a look at these two. Go to the front. You see the water wheel below is rotated. And the design elements connected to the cup, however, is each the same. A water outflow and then a socket for the piece to come in. But I only have one sketch. and didn't really make a new sketch for the other objects where the pieces are rotated. Because, before we actually continue, I would like to point this out. I select these two faces here. They kind of like define and pull the others. Go to rotate. So this snapped actually to the axis. Yeah, this is correct because I don't have a sketch. It snapped to something different. So I turned on the sketch. You see then you get better snapping abilities. And check this out now. How I'm rotating this and everything follows. How cool is that? So you see, you don't need to have multiple sketches when something like this can be rotated around a shared axis. Sketch in one time and then just move your copies. Perfect. So the reason also why I moved this was, you see here there is an interesting axis. I would like to create now a sketch of an arm that flows right into that cylinder. How do I make sure all this actually fits perfectly? So I select this cylinder, and then I can add an axis there. Now, because I rotated everything and I modeled everything around the z-axis, this, since it's also rotated 90 degrees, is sitting on the x and z plane. So that means, okay, let's go to up view. I will move this up to there. Very good. Then let's add a sketch. I will hide this. And I need 1, 2, 3, 4, and there, snap to it. And look at that. It actually projects that axis as a line into my sketch. Oh, why did I do this? So at this point, I can make tangent to this line by selecting this line and say tangent. And also here, I can draw a line and make this tangent, make this, for example, horizontal. I will lock this just for the sake of demonstration. Now I can move this left and right, but I can't move this up or down. And the same here, left, right doesn't work, only up and down. And then this way, very easily, I can create a nice flow of a curve where actually from this line, we do an extrusion that flows tangent into here and then terminates tangent into a line. A little tip if you want to have beautiful transitions. So 1, 2, there, 1, 2, and there. Zack, and zack. So you want to ideally have 2 points being tangent to this line. This simply makes actually the transition of this curve to the line smoother. So when I move this one up, there you can see how just there's a transition. And you see this is much flatter now. So it's still a tangent transition, but it has more the look of a G2 transition. Okay. I have also here this ring. So there we are. I'm actually hiding this. Let's see. I want to take a look at this and take a look at my sketch. Okay, so there's just the sketch folder. So with all this done, you see in my other sketch here, I have all these elements. Then I could go ahead and start extruding everything out. To make the next steps a little bit easier to follow, I'm just removing the elements here and go back to the pieces we already have. Okay, and it also means that you and you, I will bring you to there. Okay, very good. Very nice. And then we can do the same. These two faces. And I will bring those two there. Cool. Okay, so let's hide this. So I can select this profile. This is actually from the original circle, which I used to do the extrude. And then here I did an offset of that circle for cutting. And this circle now I can also use for the spline to do a sweep. And then this I could use to sweep along there. Then I have a line. But I would like actually, how could I say that, this to be, the radius has to be smaller. So here, this we can actually extend as much as needed. This goes into the body at one point, then we have to design the end because this will be a snap mechanism. And for our water wheel, we need to have a small, tiny axis. Let me go to the top view. And you see actually right there, this is where the spline ends. And when we go to a side view, this is actually important to point out, you see how initially the sketch also terminates on a grid. The reason why I'm pointing this out is when this is my axis, it is actually very easy in this top view then to see where it is and simply draw myself a circle that is right aligned to the grid. And in this way, that's simply how I managed to create a circle that is kind of like centered on this line. So now complicated finding or drawing a circle perpendicular to a line. So there it is. I can extrude this one down and join it. And this is now the axis. And from this center one, then I could create another ring like this. I also then, from the side, you see this is right under the z-axis, so I make use of this too, which means when I select this and do a new body, again, you see how much I'm using the grid, 20 millimeters, easy, okay, then this will be 40. There we are, cool. Also here, I will extrude this down by 1 millimeter in new body, and this will then be 2 millimeters. Double tap, 3D widget to here, and make a rotation 180. Select both, 60 and 120. Select all those, enter ring, and to be careful that you really double tap an object, union. Cool. Okay, now you see now that we actually created this piece that is inside, and when I select this one and hide it, you see there is actually a different sketch on top. So let's also hide this one. How do we now do something that is actually smaller? I need to modify this arm, but I want actually the shape of the arm to be more, I don't have to redraw it. So there's also a nice sketch trick. So this is the axis line. You see I can dimension it. Here is the endpoint of this line that goes tangent to there. And here I have a line. And this line, let me delete this. I just drew between this fit, and not fit, but control point and this line. I make them tangent, or I could also simply make them horizontal there. And when I just move this point, you see this way I make sure that they're horizontal, but I don't really want to change the size here. So I can select these 2 points and then move it. And you see now how I'm just moving these 2 points, and the rest of my spline on top simply adjusts a little bit. So it's just one easy way how, for example, I could create relationships between the curves and how everything could be modeled. So I can bring this to there and then select this. Oh, interesting. Okay, so you notice what happened here. So this actually did ignore this line. Okay, so let me go back, delete this. Now we can also move those actually together. Okay, good. Something is going a haywire here. Not a big deal. We can maybe, based on how I created everything, I corrupted this a little bit. So this is the tangent there, and here. Okay. Tangent. This is important. Tangent. There. Now you see how this works. Okay. Very good. Good, this happened because it showed you how sometimes you have to rebuild something. This is all a sketch solver. So the engine tries to solve a lot of these problems for you. So you want to be sometimes mindful of it, and because sometimes the software can predict it incorrectly. So then we can adjust these parts or leave it. These points I leave so that the beginning of the curve is always the same, just the end is a little bit different. So now I have this element, so I can extrude this out. So 11, very nice. So, and then I could extrude this out another 11. There's now my main piece. I can also select this face of the body, select this line and do a sweep. And now we can also do an extrude. This is a tick too big. Or is this maybe a tick too big? So we can see that this is my original ring. So we made a mistake. This is actually good, but not this one. How do we fix this? Super easy. Select both faces, click on this, and then we offset this by 1 millimeter. But then you see it did it this way. Okay, so let's go back. So U to U, do a sweep, but does this then actually join the piece? No, it does not. Very good. There, very nice. So I think I joined them together. There we are. And then these two we fuse together. Cool. Yeah, and then it would pretty much be the same process of modeling everything. I would like to point out one interesting element here. Oops, wrong one. Let's go to there. And 11. Then this should be 22. And this one here I will select and make this 2 millimeters as a new body. And it's a little bit offset, and that is actually okay. And then I could go 60, 120, 180, 240, and 300. So you see they have, there's a little bit of an offset. And the main reason there is the force, and the gravity force, actually the water outlet would give actually on these wheels when, for example, it is like this. So you see the water hits it and then pushes the wheel a little bit more. This rotation tool is also really nice to see, is this okay? Is this a tick too tight? This is all good. If it's too tight, then either we have to adjust the sketch. You see here I locked this line. Then the arc is tangent to these lines. The dimension is set for the radius. Then I could move this up and down and simply adjust the arc. Very good. Let me select all these elements and remove them and go back to this view. And this pretty much sums up the process how I, after some studies in sketching and basic modeling, created this a rather simplistic set of sketches that includes multiple variations and views all in one. And then via direct modeling and moving these sketches around a little bit, I very aptly then created these individual variations for such a bathroom water toy.